In this tutorial, I'm going to show you how to load your newly created run file into ETABS. Let's first take a look at the inputs that you'll need to put in MATLAB prior to running the script. You will need to set the read-in directory so that MATLAB can obtain the Revit to Excel spreadsheet, as well as an output directory where the ETABS run file will be located. Please also set the base level that is in your model at elevation 0. In our case, the base level is level 1. This is the file that MATLAB reads in that should be placed in your read-in directory. Let me show you how to import the run file into ETABS. Click on File, Import, ETABS text file. Take a look at the 3D view to ensure that the geometry looks correct. We will need to fix the joint story assignments for the braces that are connected to the base level columns. Click on Analyze, check Model, Joint Story Assignment. Click on Yes. In the 3D view, select all of your elements so that we can merge all the nodes. Click Edit, Merge Joints. Note that you will need to verify that the local axis is pointing in the right direction after you merge the joints in your model. Let's go to a plan view. To view the local axis, click on the Set Display Options icon. Under the Object Assignments, check the local axis. You can see in this plan that there are two beams with the incorrect local axis. Let's select them now. Let's go up to the next floor. After we have selected all the incorrect beams at each level, let's change the direction under the Edit menu. Edit Frames, Reverse Frame Connectivity. You will need to pay particular attention to local axis for skewed beams. Before we analyze the model, let's verify that our loads are correct. You can see that the section property is assigned correctly to this floor. As well as the loads. Let's check the line and point loads in the 3D view. Let's verify that the line loads are in the correct location with the Revit model. You can see the two line loads here. The force value is correct. Let's run a modal analysis to make sure that there are no discontinuities in the model. Click on the Analyze tab, Set Load Cases to Run. Select Run, Do Not Run All. Now select only the modal case to run only this case. Now click on Run Now. You can see that these numbers at the bottom of your screen are close to 0, which indicates that all the geometry is connected. Once again, click on the Analyze tab, Set Load Cases to Run. Before we click on Run Now, let's select all of our beams in our model. to overwrite the frame design procedure. Click on the Select tab, select Labels, Frame Labels. Select all the frame labels with the letter B in front of the numbers. And click Select. Click on the Design tab, Overwrite Frame Design Procedure, and select Composite Beam Design. Note that ETABS will still design the beams as non-composite, but make sure that you override the top flange bracing for the non-composite beams. The purpose of doing this is to have both the composite and non-composite beams exported to Excel from the same table. Please note that HSS members and K-joist cannot be overwritten to composite beam design, therefore you'll need to obtain their sizes from the steel frame design. Click on the Run Analysis icon. Let's click on the steel frame design icon to design the braces and columns. Let's reiterate the analysis and design. Now let's design all of our steel beams. Once the analysis is complete, click on the Display tab and Show Tables. Navigate to Composite Beam Design and click on Composite Beam Summary. Right-click anywhere in the table and select Export to Excel. Let's quickly take a look at the new beam sizes Excel spreadsheet. The following table shows the information that we'll need from the tables created from ETABS. Let's remove the unnecessary data. Select all the data in the spreadsheet by hitting Ctrl-A on your keyboard. Go to the Data tab, Sort by column A, and ensure that smallest to largest is selected. Now press Ctrl-F on your keyboard. Select the Replace tab and type in a capital X and replace with a lowercase x. Select Replace All. Press Ctrl-A again on your keyboard, Ctrl-C, and paste into the new sizes spreadsheet. The spreadsheet will highlight where you have negative reactions. For rounding up purposes, change these reactions to positive. Let's save the spreadsheet and obtain the columns and braces. Click on the Display tab, Show Tables, uncheck Composite Beam Summary, click on the plus sign next to Steel Design, and select Steel Frame Summary. Once again, right-click in the table and export to Excel. Within the Steel Frame Summary table, you will need to remove any duplicate column and brace names. Let's remove the unnecessary data. Press Ctrl-A on your keyboard, click on the Data tab, Sort, column A, smallest to largest. Insert a space between the column and braces. Click on column B and remove it from the spreadsheet. Select all your columns and copy and paste them into the new sizes spreadsheet. Select all the new brace sizes and copy and paste them into the new sizes spreadsheet. Let's verify the unique name with the unique name that is in Revit for our beams, columns, and braces. For our beams, we have unique names 1 through 198. Select the structural framing schedule and verify that these numbers are the same. Let's check the columns. And finally, let's check the braces. 231 through 270. Save and close the Excel spreadsheet. Let's open Level 2 Framing Plan. Let's tag all of our beam sizes and start and end reactions. Click on the Annotate tab, Beam Annotations. Make sure that the Start Shear Reaction tag is selected. Make sure the Structural Framing tag with studs and camber is selected. And finally, make sure that the End Reaction tag is selected. Click on OK. Let's view the beam sizes and end reactions. Repeat this on each floor plan. Before we open up Dynamo, we must make sure that all the beam and column sizes exist in the model. The best way to determine that is to load all the wide flange column sizes into the model, as well as all of the wide flange beam sizes into the model. Let's go to the 3D view. Now let's open Dynamo. Select the Excel to Revit Dynamo file. Click on Run at the bottom left-hand side of your screen. You can see that the new sizes have been imported correctly into the Revit model. Let's take a look at Level 2 Framing Plan. Notice that all the framing sizes have been updated with beam end reactions, stud count, and camber size. Let's take a look at the column schedule. As well as the brace frame schedule. Thank you for taking the time to view this tutorial. I hope you have found that this tutorial has been helpful for converting your Revit model to ETABS.